The following is the video solution from JSDT Solutions. Question 1.1.1, we are told to solve for x if x multiplied by x minus 3 is equal to 0. So the idea behind this is we have some number multiplied by another number, and it gives us 0. Well, the only way this is possible is if the first number is equal to 0, and then you said 0 times the other number, and then it gave you 0, or if you have the case where the first number multiplied by the second number, and the second number happened to be 0, and then that gave you 0. Okay, so to solve for this question, we simply say that it's either that x is equal to 0 or x minus 3 is equal to 0. Therefore here, if we solve for x is equal to 3, and those are our solutions. Question 1.1.2, we are given a quadratic equation and we are told to solve for x correct to 2 decimal places. Now, we know this is quadratic because you can see that the highest exponent on x is a 2. And with that being said, this is not in the standard format of a quadratic equation. So the standard format of a quadratic equation is ax squared plus bx plus c is equal to 0. And so from that, you can see that one-hand side of this equation is not equal to 0. So we're going to have to take the 4x over to make sure that this is in its standard form. So we're going to have 2x squared and then minus 4x plus 1 is equal to 0. Okay, great. So now that it is in its standard form, we know that we have to correct to 2 decimal places, meaning our solutions are going to be irrational. Okay, so that means that we need to use the quadratic formula, which looks like this. And now that we have the quadratic formula, we can just substitute our values of a, b, and c. So from our equation, we can see now that a is 2, b is negative 4, and c is positive 1. So let's go ahead and substitute that in place of a, b, and c. So now that we have substituted, we can find the values of x. Okay, so x is finally equal to, and starting with the negative, okay, we have this, which needs to be in decimals. So that is going to be 0 point, and you're rounding off to 2 decimal places. You see, after the second decimal place, we have 2, so this rounds down. So this is 29. And you can just go ahead and change that negative to a positive, and now we have 1.7, and that is going to round up, adding a 1 to the 0. And those are our solutions. Question 1.1.3, we are asked to solve for x given this quadratic inequality. Okay, because we have a quadratic expression on this hand side, we have to factorize this. So to factorize this expression, we're going to go ahead and open up 2 brackets, and it is still greater than 0. And then ask ourselves, what multiplied by what gives you x squared? And that would be x multiplied by x. And then what multiplied by what gives you a negative 3? And that would be, well, the factors of 3 would be 3 and 1. But you know that it should give you a negative 3, so 1 should be negative and 1 should be positive. So to decide which factors should be negative, you can focus on the coefficient of your middle term, which should be negative so that this remains negative. So we can give the negative to the bigger factor. So if you make that minus 3 and positive 1, you know that negative 3 plus 1 really does give you negative 2. Okay, so now that we have factorized this, we can move on to solving for x. Since we have an inequality, we're going to set down our critical values. So our critical values are really just those points that mark where our solutions start. And they really just work like solving for x. So if you're solving for x in this equation, x minus 3 equals 0, then your critical value would be x is equal to 3. Then if you were solving for x in this equation that is set equal to 0, then x would be equal to negative 1. And now that we have our critical values, we can go ahead and draw our parabola. So from the equation that we have, you can see that the coefficient of x squared, a, is equal to 1. And if it's equal to 1, it means that a is greater than 0, meaning we are going to have a concave up parabola. And then we can also just include our x-axis. So we'll put our critical values down. Remember, they are points where the y value is equal to 0. If you had to make that equation equal to 0, that's where you get your critical values. So it means that x here would be -1 and x here would be 3. Okay, so that's the smaller, that's the bigger. And now we have to answer the inequality. The inequality specifically says that this expression needs to be greater than 0, meaning when you substitute x values here, that those x values produce a result that is greater than 0. The result we get are y values. So they're really saying, where are your y values greater than 0? Okay, so we can look at this by looking at the y-axis quickly. You see that on the y-axis, you have places where the y values are specifically greater than 0 and places where they are less than 0. We need it to be greater than 0. So let's look for the places where the y values are greater than 0. If you look at these points over here, the points down here, do you see that they map to y values that are less than 0? So we know we are definitely not taking any of those. You need to take ones that are greater than 0, meaning you need to take every part of the graph that lies above the x-axis. Okay, so that will be over there and over there. And at this point, we don't need any of this anymore. So to find out where exactly these x values are, we can line them down to the x-axis. So we're lining them down to the x-axis so we can find out where they are relative to these critical values. Do you see that these are values that lie to the left of -1? So they're moving towards that direction. And so what that means for -1 is that our solutions lie where x is less than -1. Okay, so do you see that the direction helps you with the inequality? And on this side, you can see that these, if we line them down to the x-axis, they're moving towards the right-hand side, okay, of 3. So this would mean, so we can tell them, or x is greater than 3. Again, the direction helps you with the inequality. And those would be our solutions. Of course, you could also write these in interval notation. So if you wrote it in interval notation, it would look like this. We're basically saying that the x values, okay, if you look at it on the number line, you will better be able to understand it. When writing in interval notation, we say x is an element of, and then you're always going to read your intervals from the left-hand side to the right-hand side because it's all through here. So you can see where they start would be at -infinity. So we say that it's going from -infinity and then it ends at -1. Not exactly at -1 because remember this says just greater than 0, not greater or equal to 0. So we'll close that bracket there and then we can say or you could also just say union, which is really just the symbol for or. We know this from probability and then we can go ahead and write that as well. So x is greater than 3, it starts at 3 and then it heads towards positive infinity. So it starts not exactly at 3, but just after 3 because it's not equal to 3. And then it ends at positive infinity. And those would be our solutions. You can either write it like that or like that. Question 1.1.4, we are given an exponential equation and we have to solve for x. So we know it is exponential because the x's are in the exponents. So in this exponential equation, one thing you're going to notice is that there is a repetition of a specific term, which is really 2 to the power of x. We have 2 to the power of x here. Of course, it's 2 to the power of 2x. But if you wrote it as 2 to the power of x and then raised to the power of 2, then it still means the same thing since you would have to multiply the exponents. So we could also rewrite that so that we can clearly see the 2 to the power of x being repeated. So that's minus and we have 2 to the power of x. Then we have a plus 2 in the exponent. So what that means is you must have multiplied by something that was written with its base being 2 and then you had an exponent of 2. Since when the bases are exactly the same and we are multiplying, you end up adding the exponents. And then of course we have the minus 32 is equal to 0. Okay, so this is our equation. And now we are going to use a method that makes this simpler to solve for. And that is called the K method. So with the K method, it really just says you need to let K be equal to whatever was repeated, which was the 2 to the power of x, which we can see repeating there. So we say let k be equal to 2 to the power of x. So this means that our equation is now that would be replaced with k, so k squared minus, and then that would be replaced with k. But you can see that this is 2 to the power of 2. So let's just rewrite it as a single number. Now 2 squared is 4, and then we have 2 to the power of x, which we replace with k, and then minus 32 is equal to 0. Okay, great. We have something that looks more familiar. This is a quadratic equation where we have to solve for k. So we can open up two brackets, set it equal to 0, and then we have what times what gives you k squared, which is k times k, and what times what would give you 32, specifically negative 32. Well, with this, you're going to have to choose factors that are really just close together. They're not really that far apart. So something like 2 and 16 is definitely not going to work because 16 is way too big. So let's try 4 and 8. Okay, so now we know one of it needs to be negative since 32 is negative. Which should be negative so that the middle remains negative? The 8, the bigger factor. So if this is positive 4 and negative 8, we know positive 4 minus 8 is equal to negative 4. Okay, so let's solve for k. This therefore means that k is equal to negative 4 or k is equal to positive 8. But remember, the question is to solve for x, not k, so we're not done. We need to solve for x, meaning we can go back to what k was, what we replaced with k, and that was 2 to the power of x. K was 2 to the power of x. So this means that 2 to the power of x is equal to negative 4, or 2 to the power of x is equal to 8. Okay, let's talk about the first one. We have 2 to the power of x equals negative 4. Is that possible? Can you take 2 and raise it to an exponent and then it gives you a number less than 0? If you try different numbers, if you try negative 1, you will notice that will give you a half. Try negative 2, it's going to give you a quarter. If you try positive numbers like 2, that's going to give you 4. So do you see that this will never be possible? It is not possible to raise a base of 2 to any number and get a negative solution. So this cannot happen, and we'll just say that 2 to the power of x therefore can never be equal to negative 4. And now moving on to this. Okay, we have 2 to the power of x equals 8. The left-hand side needs to be equal to the right-hand side. So why don't we just rewrite 8 so that its base is 2? So that will be 2 to the power of x is equal to 2 to the power of what gives you 8? It will be 2 to the power of 3. And now do you see that only if x is equal to 3, your left-hand side will look perfectly like your right-hand side. And so therefore, x is equal to 3 only. And that is the answer to that question. Question 1.1.5, we are given an equation and you can see that there is a surd in this equation and we need to solve for x. Okay, so straight away we can see the major problem here would be this surd. We need to get rid of it. So the best way to get rid of this surd is to isolate it. Leave it on its own on one side and take whatever is not in the surd over. So negative x is going to go over. So when we rewrite this, this is the square root of negative 2x plus 4 is equal to, and I know there's a 2 here, but this becomes positive. So we might as well just write it before the 2. So that 2 was also positive, so it stays positive 2. Okay, so now that we have this, we can get rid of this square root. And the way we can get rid of a square root is by squaring it. So we will square that. But this is an equation, and what you do on this side, you have to do on the right-hand side as well. So this means that they break open because they're the inverse of each other really. And we have negative 2x plus 4 is equal to, and then we have this. Now you have the choice to either simplify this by saying x plus 2 times x plus 2, which I think takes a while. So I'm going to deal with this using a simple method. During your exam, you want to make sure that you save as much time as you can. Using this method, we first square the first term, which is x squared, and then square the last term, which will give you positive 4. Then say the first term multiplied by the second term, which will give you 2x, and then this needs to double. So you multiply it by 2. And so that gives you a positive 4x. Okay, this looks good now, and we just need to solve for x. So to solve for x, bring all the like terms together. So we're taking all of that over. So this means we'll have nothing over here. 0 is equal to x squared and then plus 4x. And when you take this over, it becomes a positive 2x. Those added together give you positive 6x. And then we have positive 4, and you can see that they're exactly the same. They would have already cancelled on both hand sides because we have positive 4 and that comes over and becomes a negative. Okay, so this is really all we have, and we have to solve for x. You have a binomial, 2 terms. To solve for x here, you can factorize, but we can't use trinomial factorization because there are only 2 terms. So what type of factorization can you use here? You can use highest common factor. So let's take out the highest common factor from the first and second term. That would be exactly x. And taking that out, what are you left with in the first term if x is your factor? X times what gives you x squared? X times x. And then in the second term, x times what gives you positive 6x? That would be positive 6. Now that we have this, we have something multiplied by another thing give you 0. The only way that's possible is if the first number is equal to 0 or the second value is equal to 0 as well. So here, if you solve x, x will simply be equal to negative 6. So our solutions are x is equal to 0 or x equals negative 6. But slow down. We still have to find out whether this is actually true or not. Because do you see that this is an equation with surds? And what we did here was we squared both hand sides. That tends to tamper with the solution. So you need to check whether your solutions are actually valid. So to do this, it is quite simple, and you can even use a calculator to do this. You are simply trying to ensure that the left-hand side really is equal to the right-hand side. So when x is equal to 0, we will substitute in place of x, we'll substitute 0 and find out if our left-hand side really is equal to 2. And you see that when we substitute 0, that we get an answer of 2, meaning the left-hand side really is equal to the right-hand side for x equals 0. Now let's try that with negative 6. If you substitute negative 6 in place of 0, what do we get? So that's minus and of course minus 6, which gives you 10. That is not true. That solution gives us 10 instead of 2. So we are going to cancel that solution and x is therefore equal to 0 only. And that is the solution to this question. Question 1.2 asks us to solve for x and y simultaneously. Okay, so with these, we can look at these two equations and choose the equation where something, a variable, can be made easily a subject. So from this, do you see that in this linear equation, you have y on its own. So we can easily make y the subject here. So we can call this our equation 1, and then that will be by default equation 2. So now we can form equation 3 using equation 1. You can leave y on the left-hand side, and we have y is equal to, and you still have 3 on the right, and then take your 2x over. And this is now our equation 3. Okay, now to solve for x, we can go ahead and substitute equation 3 into equation 2. So wherever you see y, substitute it with 3 minus 2x. So we have y squared. So in place of that squared, we're going to say 3 minus 2x. And then we have plus x and then multiply by 1. So we'll replace it with 3 minus 2x. And then this is equal to 2. Okay, so let's go ahead and simplify. Simplifying this, we square the 3 and that gives you 9. Square the negative 2x and that gives you positive 4x squared. Then first term times second term, which gives you negative 6x. And then you double that, multiply by 2, which gives you negative 12x. And then we have these, which we can distribute, and that's going to be positive 3x and negative 2x squared. Now we can just go ahead and take this over, so it's minus 2 is equal to 0. Okay, now we can put our like terms together. So in the order of its exponents, those two go together and become 2x squared. These two go together and they become negative 9x. And then lastly, the constant. So 9 minus 2 gives you positive 7 is equal to 0. Okay, now that we have this, let's go ahead and factorize. So we can use the factor method here So we'll multiply the coefficients of the first term and the constant. And that would give us 14. Now, this 14, we are going to use this and find the factors of 14. That would give us the coefficient of the middle term. So it works a lot like factorizing simple quadratic equations. So what are two numbers that we multiply that can give us 14, but when added together, they give you a negative 9? That would be 7 and 2. Okay, but do you see that this is negative? So the only way that that could stay negative when added together, but at the same time stay negative when you multiply them together, is if they were both negative. So negative 7 times negative 2 is positive 14, but negative 7 minus 2 is negative 9. Okay, so this is how we're going to rewrite this here. It is 2x squared, and then we are going to rewrite these in terms of x, because you see that they add up to negative 9. So we are rewriting negative 9 as negative 7 minus 2. But we're not just going to put them in any order. You're going to put the negative 2 with the 2x squared because it shares a common factor with it. But remember that we are trying to represent negative 9x, which is already in terms of x. So this is negative 2x. And then this is going to be negative 7x. And then we continue with our equation. Plus 7 is equal to 0. And now we can use grouping. So we group these two together and these two together. So take out the highest common factor between these two terms. That's going to be 2x. And then what are you left with? In the first term, you'll be left with just x. And in the second term, you'll be left with negative 1. Okay, second term. Take out a common factor. That would be negative 7. And what are you left with in the first term? That would be x. And in the second term, minus 1 is equal to 0. Okay, do you see that in this new simplified equation, all that is common between the two terms that we have, because that's what we have, two terms, would be the brackets. So we're now going to take the brackets out as a common factor. So we have x minus 1 that comes out. And then what is left in the first term after taking out that common factor? It's going to be the 2x. And in the second term, you're left with negative 7 is equal to 0. And now we can go ahead and solve for x. So here, x is equal to 1, and then here we can straight away say 2x is equal to positive 7 because we're taking the negative 7 over since they're equated to 0, and then divide both hand sides by 2, which just gives you 7 over 2. Okay, so we have solved for x, but remember the question asks you to solve for x and y. So which equation could we use to solve for y? Well, use the equation that already has y as a subject, so that would be equation 3. So you can go ahead and call this equation 4 because they are equations. They say something is equal to another thing. And so substitute equation 4 into equation 3. So equation 3 is y equals 3 minus 2x. So we'll say y equals 3 minus 2 and then substitute the x value. The first x value we have is 1 and y equals 3 minus, that's just 2 times 1. So that is 1. Or the second solution would be 3 minus 2 times 7 over 2. And then you see here that the 2 and the 2 in the numerator and denominator cancel, and you have 3 minus 7, which is negative 4. And those are our answers. X equals 1 while y is equal to 1, or x is equal to 7 over 2 while y is equal to negative 4. Question 1.3 says, consider the product, and then we are given these and they are multiplying. Now they tell us that each factor in the product is of the form 1 plus 1 over n, for where n is greater than or equal to 2, which we can see it starts at 2 and then it increases so its value is greater than 2. Then they ask us to determine all the values of n for which the product will be an integer value. So from this, the main goal is to find the product. And you find the product by simplifying these that are multiplying together. So how about we take this and simplify it further, because right now they are in the form of whole numbers plus fractions, and we could just rewrite them as improper fractions. So to simplify this further, we can just add them together. So that would give you 3 over 2. This would give you 4 over 3. And then the last one would give us 5 over 4. And this keeps going on. Now to find out how we can multiply this, let's find out where it would end. So let's go ahead and write down a factor that would represent the last term. Regardless of whatever it is, we know that it's going to have this form. So it's going to be in the form of 1 plus 1 over n. Now, of course, we could also represent that here. Just see this as it's 1 plus 1 over n. 1 over n is a fraction. So we could rewrite 1 as a fraction as well so they can be added together, but the denominators need to be the same. So you're really just taking 1 and you're multiplying it by n over n. And you're adding this to 1 over n. So on the numerator, you'll just have n plus 1, and on the denominator, your denominator will stay exactly the same. So n plus 1 over n is our last term, and this is what we have so far. So let's go ahead and simplify this further. Do you see that as these fractions multiply, the numerator of the current term and the denominator of the next term would cancel? Same thing would happen here. This 4 and this 4 would cancel, and this 5 and the next 5 would cancel. Okay, so it means something here would cancel. Let's go ahead and write a second last term so we can understand how this works out. As you can see, these factors are increasing by 1. So it means that if you had n plus 1 as your last term, the numerator of your last term, the previous term would just be 1 less than this. So this would be n plus 1 minus 1, which is n. And the denominator would also be 1 less than that. So it would be n minus 1. And so this is what it would look like. Now, cancelling, we can see what happens. You see how the n here would cancel with this next n in the denominator? It's the same way we would have had an n minus 1, a previous term here, cancel with the second last term, whatever that second last term is. And remember, what they're doing when they're cancelling is they're really just dividing, because had you had these together and you had to write it as a fraction, then do you see that the 4 and 4 would cancel because they're really dividing by each other and becoming 1. So if we rewrite this, all we'll have left is in the numerator, we'll have n plus 1, and in the denominator, the only thing that would not cancel would be the 2. So this is in fact the product. Now the main question is to determine all the values of n for which the product will be an integer value. So for which values of n will this remain an integer value? For this to remain an integer value, then because it's divided by 2, then you need to ensure that the number on top is also divisible by 2. In other words, we're really saying that n plus 1 needs to be even. It must be even. But the question is not specifically asking for n plus 1. It's asking for all the values of n. So it means that if n plus 1 must be even, then n specifically must be odd. That is the only way this would be even, because if you take an odd number and you add 1, it will make it even. So is it just odd for all values of n, or should we restrict it? Do you see that at first we already had it being restricted? N had to be greater than or equal to 2. So you can see from this, we're not considering any negative numbers. So what does n have to be to satisfy this? We can see from the product that when n is equal to exactly 2, then this becomes 3 over 2, which is not an integer value. But when n is values that are greater than 2, then we have 4 over 2, which is 2. And also remember, n specifically has to be odd. So it's contradicting to say that n should somehow be equal to 2. So it can't be greater or equal to 2. Rather, it's just going to be greater than 2, since no negative values are considered here. So as long as n is odd, where all the n values are greater than 2, then the product will always be an integer value. And that is the answer to that question.